Stephen Hawking. So he said that before he passed away a few years back, he said that so we all have only 100 years on Earth, maybe for whatever reasons. So it may be because of our own doing, like whatever we are polluting with plastic, or it might be because of some nuclear bombs, or it can be a natural thing like whatever destroyed entire, like whatever extincted all the dinosaurs and everything, that asteroid event. Fortunately, so we are very very safe as of now. We don't know why no other asteroid has hit in last 60 million years. So we are really fortunate about that. Or the current favorite AI. So Terminator. So whatever the reason might be. So he mentioned that we have only 100 years. That was almost like 5 years back. That means that we have only some 95 years. So if we are forced to leave our planet Earth, our Vasundhara, so then we can't actually, the next day we cannot actually hire a Uber ISRO satellite and just jump off from here. So we have to do a lot of preparation for that. So one of the starting points is moon. So before going to that itself, I'll tell you why moon is so important in our life for the origin of life on Earth, and keeping the life alive on Earth. For everything, we are depending on moon. Maybe many of you are already aware of this. I'm just going to give you a little bit introduction about that. And all the recent studies and the research are also pointing towards the extinction event, which is imminent. When is the question? It may not be 100 years, it cannot be, it may be 200 years, but extinction is going to be sure. In addition to death, extinction is the other surety. So that to the level that 2 years back there was a study showing that humans are taking out the water so much that even it is actually affecting the tilt of the earth. That's the kind of effect we have in addition to whatever the pollution we are doing. So because of this, we are forced to leave Earth. If that's the case, then where will we go? And we cannot simply, without walking, we cannot start running or jumping. So this is our first point. Why we go to moon first is, moon is, as you know, one of the airless body or no atmosphere there. So easy to learn or get familiar with how to land and get experience with the landing and other details. So this is the starting point for us. Not only this, why we actually do this and everything, I'm going to discuss in my lecture. So this is my plan of talk. I'm going to introduce you why we need to study moon, and then what are the ISRO's Chandrayaan missions, what we have done, what we are planning to do, and what it is now at moon. Then we are not only talking about ISRO's Chandrayaan missions, yeah, I'm also going to introduce you to ISRO's planetary exploration and astronomy missions, and what are the plans ISRO has for future. And then I might even touch upon Gaganyaan and BAS, Bharatiya Antariksha Station. Okay, so you are all aware of this inner solar system. Among the inner solar system, only 2 planets have satellites. And not only inner solar system, entire solar system, our moon is very, very special. What way? So if you see the size of the ratio, you take the not just the size of the moon alone, you take the ratio. For example, this is the largest satellite in our largest moon in our solar system. So when I'm talking about satellites and others, I'll be interchanging moon with the Earth's moon and all the other satellites. Okay, so astronomers are very good in actually using order of magnitude estimates. If I say 1,000 kilometers, it can be 9,990 kilometers, or it can be 100 kilometers. Like that, when I say moon, it can be our own moon or any satellite of the any satellite. So if you take all the satellites in the solar system, Ganymede is the biggest one, that is around 5,300 kilometers, whereas our moon is 3,200 kilometers. Even then, I'm saying that it is one of the biggest moon. The reason is you take the ratio. So it's almost 4 times as big as our Earth. Sorry, 1/4 of our Earth. Whereas even though Ganymede is so big, in front of Jupiter, it is up to the scale. It looks very, very tiny. So in that way, this is very, very important. Our moon is very, very important. So what? Size doesn't matter, right? So how exactly size is coming into picture? The reason is this one. So in astronomy, one of the major questions everybody asks is from where exactly we came into existence. When I say we, life came into existence on Earth. So this is one of the fundamental questions after how actually universe came into existence. So now there are several searches. You might have heard of SETI, search for extraterrestrial intelligence. It went for decades and finally they are almost stopping. This stopped, right? Almost. Funding goes up. Funding is problematic. So, and then why we haven't, we are unable to see life or any other place. This is a picture I just took it from Google. It shows a um, small percentage of butterfly species seen on Earth. Okay, so if I put why I'm putting this here is after that extinction event, whatever I talked about in the first slide about when the dinosaurs went off, that the extinction event that not only took by dinosaurs away, it took almost 90% of species on Earth. Whatever we have here is only remaining 10%. That 10% itself corresponds to 87 lakh species. And butterfly is only a small portion of that. Okay, so it's a fair, there is a lot of different species on Earth. And then, I don't know, I missed a image here. I had put, you might have heard of this pale blue dot. Okay, so that clearly shows that Earth is very, very small speck in the space. So our galaxy has 10 to the power of 12 stars. So even if you take the usual way of saying that 1 in a million, so assume that 1 in a million of these stars have planets. And even if you take 1 in a million of those planets has life, that means that we will have thousands of thousands planets should be having life in our solar, in our galaxy, Milky Way galaxy. And there are thousands, millions of such galaxies, even billions actually. We have such galaxies throughout the universe. Then why Earth is so special that we are unable to find life anywhere other than Earth? Okay, so that's one of the questions which always comes into mind. So the one of the reasons they say is this may be because of the presence of moon, not just moon, the size of the moon. So we don't know till now how the life came into existence, but we know how the building blocks of that life, that is DNA and RNA, are produced on Earth. Okay, so these DNA and RNA, they replicate. Both of them replicate. And when they, what do you mean by replicate? Like a zipper, they'll come and join together. And problem is, most of these things have phosphate in that. The four parts of that DNA and RNA has phosphates. These phosphates do not like to come together and join. Okay, so then how are they? How can the these chains can be formed? When the two phosphate molecules are like not allowed to come closer. So then somehow you have to make them come and join together. That happens in saline water. Okay, so where do you get saline water? In sea. So in the sea, assume that the two phosphate molecules are coming and joining and it becomes a cycle, this chain, and then this chain will attract more, so it will grow. After some time, all the phosphate molecules in that area will be gone. So then it will stop. The chain formation of chains will stop. So then because there are no phosphate molecules anymore, but because of moon, we have tides. So these tides in one way, actually they mix up water, seawater. So then that means that the phosphate from the other parts of the sea can come there and this chain can continue forever, as long as possible, as long as required. So we are preparing the blocks, building blocks. Those are the, it's ready. How exactly the life came into existence, we don't know, but at least we know how what are the ingredients which are required for that. Okay, and also the tides are also responsible. Whenever there is a tide, it comes onto the ground, and then when it recedes, it leaves puddles there. So these puddles, when they evaporate, the salinity increases. So wherever the salinity increases, the ease with which these grows, that will also increase. So the chains will be much, much bigger than that. I don't know how many of you have heard of brine pools. Have you heard of brine pool? Anybody? Oh, great. So brine pool is nothing but it is a very, very salty lake inside a sea. There are multiple salty lakes inside the sea, which are clearly demarcated from the whatever the water surrounding that. You can clearly see. And people have seen that the number of organisms in that small brine lakes are many, many more, or density is so high that they are unable to identify each and every molecule and each and every organisms there. So that actually supports this idea that salinity actually helps in producing like life. Okay. How exactly? We might know sometime later. So then, this is fine. This is when the life came onto Earth. Do we really need moon even now? How? How exactly moon is going to help us other than for the poets to write love stories, poems? So the question rises here in the stability of our axis. Okay, you are all know that Earth is actually tilted at some angle, 23 degrees. Okay, so I keep forgetting that. So for me, it varies from 15 degrees to 23 degrees. So now this stability, because of moon, this is maintained within plus or minus 0.1 degree. It won't change more than 0.1 degree. So what, instead of 23 degrees, what if it becomes 0 degrees or 90 degrees? So you are all know about Mercury, right? Mercury, it's almost, the Mercury is very, very slow rotating. It takes 58 Earth days is equal to 1 Mercury day. That means that it will have 29 Earth days as night, 29 Earth days as day. Because of this, what happens? The night times of Mercury is almost like minus 200 degrees centigrade. Okay. So the coldest part on Earth is around minus 180, minus 140 or minus 180 only, 180 degree Kelvin. This is colder than that. Okay, nothing can survive it. And the hot part is almost like 400 degrees centigrade. Just because is the slowness. Assume for whatever reason, the earth tilts such that one portion will be always day, another portion is always cold, night. Then you can imagine the kind of environment you have there. How cold or how hot it will be. So it is actually earth is keeping that from happening. Okay. Then tides keeps temperatures under control. How? You might have all seen the movie Finding Nemo. So how different portions are actually goes, how it goes to Australia and comes back. In that way, what it is doing is it is mixing up that water. So some portions which was supposed to be very, very cold gets mixed with the hot streams. And so it is maintaining some balance. Otherwise, some portions will be very, very cold and some portions will be very, very hot. So not only tides in the sea, even land, because of moon, it actually compresses and expands. Not by very, very much, 35 centimeters, but this 35 centimeters is enough energy to keep New York, and it actually increases the temperature of New York by almost 10 degrees centigrade. Imagine some places, sometimes it will go to almost like minus 4 or minus 5 degrees. And if this was not there, it would have gone to minus 20, minus 30. So one of my friend was in Moscow sometime a few years back. There at one point, the temperature went to almost like minus 35 to minus 40. There he could not cry. The reason is if by chance there is a water droplet in your eye, by chance if you actually just rub it, that icicles can actually scratch your entire pupil and it will you will go this thing. So that is the problem in minus 75 to minus 30. You are talking about much, much lower temperature. So beyond all these things, I'm interested more in the last one, tectonic movements. Why tectonic movements and why trapping of carbon dioxide? See, there is a theory that both Venus and our Earth started their life are formed from almost similar material. But now you know what is the kind of environment Venus has. Its temperature is to plus 273 degrees Kelvin. Okay, no. It's a 273 centigrade, and the atmosphere is almost 95 times more than our Earth's atmosphere. Why did it happen? That is because of another buzzword, whatever we have, greenhouse effect. So what happens normally on Earth is during the day, Earth gets warm. So during the night, this whatever the higher energy is given out. in the form of infrared radiation, and it is thrown out to the space. On Venus, because of this carbon dioxide at a very, very high pressure, so this carbon dioxide, instead of allowing this to escape, it just traps it. So in the daytime, the planet gets heated up. In the nighttime, it is not allowed to radiate it away. So it keeps on increasing. The temperature keeps on increasing, like our pressure cooker. So because of this continuous heating up and no radiation, the temperature has raised to 273 degree centigrade. So we have just saved because this more than 90% of this carbon dioxide in the atmosphere got trapped in the sea by this tectonic movement and most of these shells and other forms. So in this way, our Earth was saved from the fate of Venus. So moon is very, very essential, not only for the origin of life, but also for keeping life alive. So isn't it? So this is why one of the best ways to study, if you want to search for a terrestrial life on any other place, one easy way to like closing or reduce the sample is looking for the moon. Instead of directly looking for the biosignature or biomarker, look for a big moon. Okay, so size does matter. Then this is fine. Till now it's fine. Then what might happen if suddenly moon goes off today? Okay, this is the picture. Usually whatever we see here is the picture, whatever we see all the times, moon, because of the tidal locking. I'm just saying this because for the high school students, if somebody are there. So we always see one face of the moon because of tidal locking. Okay, so we usually don't never see the other side of the moon. In the movies, they call it as dark side of the moon. What we call this far side of the moon. So see the difference between the two. By the way, being a Kannadiga, I always see instead of a rabbit on this one, I see a Karnataka map there. Okay, so assume that suddenly the moon goes off. No moon. Okay. Then many of these animals, like this dung beetle or the one I keep forgetting the name of this one, this stays very close to water, next to the sea, but it cannot stay inside the water, but it cannot be away from it because its skin is very, very fragile. It will get fried very fast. So it has to follow the tides. The only way it can follow the tides is because of moon. If the moon is not there, all these animals and similar animals who depend on the lunar GPS, they will vanish. So then the dung beetle, it actually found very, very interesting that it uses one particular polarization of the moon's light. Okay, if it is not there, they found in the laboratory where it was cut off that it started going round and round and round within the laboratory. It could never reach its burrow. So like this, there are many, many of them. Many, many animals will vanish. Okay. Then I already mentioned about stable axis and tectonic movement. Then suddenly this one tide. You know the amount of water in the tides. So if suddenly moon vanishes, all this water will fall on Earth. Once this happens, so then it will become like much, much bigger than whatever the tsunami we have in 2005. 10 times bigger than that. And the people predict that almost 3/4 of the people, entire Earth, will be affected by these tsunamis if moon vanishes suddenly. So finally, you see the difference. You remember the Karnataka map and see the difference here. See, the number of hits are many, many more compared to the face which are facing us. Okay, the reason is this is almost acting like a shield, saving Earth from meteorite hits or asteroid hits. It acts like a first one form of defense. The other one is Jupiter. I'm going to leave that to your just as a homework. So these two are saving Earth from whatever the asteroid hits, which would have the frequency would have been multiple times more than whatever we are actually seeing on Earth. Okay? So in all these ways, this moon is very, very essential, without which Earth, as we know as of today, wouldn't have exist and will not exist. Hence, we need to study moon, right? So just to tell what made moon, there are many theories. Somebody will say that one girl was crying, her ear drop, whatever the tear drop fell, and that became moon. And some people have many more stories. But what exactly might be the reason? So there are some rational thinking. So whenever most of the astronomy is like telling a story, but you use as many less variables as possible when you tell a story. So more the number of variables is, it will become more and more story than theory. So rationally thinking, Darwin proposed that moon turn off from the earth. It was rotating. I'll just come to that later. And Harald Urey actually had another theory. He said that moon was going for a walk. When earth was sitting there, it simply captured that and then made it go around. So which one is true? In addition to them, there are more theories. One is when Earth was initially formed, it was rotating much, much faster. So it was almost like, if I remember correctly, a few hours only. Instead of 24 hours now, it was only few hours. It was rotating so fast that because of centrifugal force, a portion of the Earth came out, separated from Earth, and became Moon. And by another one to say that no, both Moon and Earth formed from the same material. A small portion of that became Moon, and this one bigger portion became Earth. So there is one more theory. So all these theories are right, are there. In addition to that, people say that Earth got hit by one other planet, smaller planet. This hit actually melted it away. One portion of that was like escaped from Earth and became Moon. Okay, so there's a animation, not animation, simulation showing how it might have happened. Sound, sound. Can you hear this? So most of you might have had your breakfast around 8:30, 9 o'clock in the morning, right? Now it's 3:30, so that means that it's around 7 to 8 hours till you had breakfast. This entire process took 7.5 hours, less than the time between when you had breakfast and now. So, for me, something coming and hitting our Earth and melting it, a portion of that coming out, and both of them solidifying, it took 7.5 hours. So, so with this, we are sure that we have to study moon. Okay, this is just a justification for why we are spending so much money on lunar exploration. So, we all know this famous figure, right? Image. So three people went in the first one, and Neil Armstrong kept his first foot on the ground, and this is Buzz Aldrin standing in front of the lunar module Eagle, and that is the image taken by Chandrayaan 2, and you can clearly see the same module there. Can you see that? This. So if somebody asks you that So lunar, this one is a hoax. Lunar landing, moon landing by Americans is a hoax. You can show the image taken by us. So coming to our program, lunar program, we started our program in 2008, 2009 with Chandrayaan-1, and we have now reached to Chandrayaan-3. We have completed Chandrayaan-3, and we are planning for Chandrayaan-4 and Chandrayaan-5, our LUPEX mission. I'm going to tell about that, and maybe in the future lunar missions also. So when the Chandrayaan-1 was launched in 2008, even though 50 years before people man was landed on moon, so even after 50 years, Chandrayaan-1 was the first one to discover water on moon. It was one of the greatest achievements of mankind. Not the first one, even the seeing water on moon. Till then, nobody has detected that. And Chandrayaan-2 confirmed that the hydroxyl form not only on moon, even in the very sparse atmosphere, whatever is there on moon. Okay. Along with that, we have detected many, many more minerals on moon. So this is a water signature taken out by Chauhan et al. So we have seen that information from TMC and everything. So in addition to mapping the minerals on moon along with water, we have seen many more minerals, including argon, sodium, and many more minerals. So we have almost the entire map. The entire moon is mapped with what kind of elemental abundances are there with Chandrayaan. So Chandrayaan was launched and it has completed almost 6 years now. So Chandrayaan 2 carried one camera, high resolution camera, and that resolution is so high that no other space agency can beat the kind of resolution whatever we are providing. So that proof is there in that image of Apollo module, whatever I have shown. So then on July 2023, 14 July 2023, we started from our journey from Earth. So then to reach moon, this is Chandrayaan-3. So Chandrayaan-2, even though it has achieved most of its objectives, we failed in soft landing on moon. So we could not stop ourselves. We just crashed into that. So this is one of the major objectives in addition to other objectives. So we used a method called slingshot. You all know slingshot, right? In Kannada we call kanive. So this is to reduce the amount of energy required, and then using that we reached there and reached to 100 by 100 kilometers orbit. So what are the major goals of Chandrayaan-3 is to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, going around, and then conduct some in situ scientific experiments. So these are some of the scientific payloads on experiments on lunar Chandrayaan-3. So ILSA is a seismometer. Chaste is to look for the thermophysical property. It actually digs deeper into the moon's surface, almost up to a few tens of centimeters. And then linear probe is to look for the plasma environment around the moon. And this is from NASA. This is just an array of mirrors. So that this can using this, you can actually get the precise position of moon. Okay, so lander and then rover had alpha particle X-ray spectrometer, FX, and LITS, laser-induced breakdown spectroscopy. Spectrometer, sorry. So see, these are some of the results from that. So we could actually measure the seismicity, and then we know the composition of the elements and the temperature profile, how it went goes deeper and deeper. In addition to that, we know lunar terrain in multiple angles, multiple energy and multiple wavelengths, so that we can actually make a 3D map of the craters and everything. And this is another first. ISRO is very likes all the first. This is the first ever landing near the south lunar south polar region, and we are here today because of this event. And this site is named as Shiv Shakti by our Honorable Prime Minister. And this is India became fourth nation to achieve soft landing on the moon after USA, Russia, USA, Russia, China, and then something other than that. Okay, so these last two are required. So we have actually rover has gone around 100 meters. It took turns and everything. I'll show some videos later. So what are the next ones? Now we have achieved landing, we have achieved roving, and now what is the next thing to do? Natural thing to do? Trying to bring back some sample. So that we are going to attempt with Chandrayaan-4. So we cannot do this with one single launch. We are going to have two launches there. One of them will carry the lander and rover, whatever it is, and another one is just go along with it. And then this one will take some um, sample from the moon and launch it back. And another one will catch that and then bring it back. Okay, these two things will take a lot of technology demonstration and everything. And funnily, with Chandrayaan 3, we have already demonstrated two such technologies. I'll just talk about it later. Then in addition to that, okay, so please note down that date. Currently, we are trying to see whether we can do it in 2028. So in addition to that, we are also planning another mission to moon called Chandrayaan 5. So it is a collaboration between Japan. So this is called LUPEX mission. Okay, lunar polar exploration mission, LUPEX mission. So this is also going to go very close to lunar south pole. There also we are going to dig some sample, and that sample we'll keep it ready, but we're not trying to bring back. So this is a, as I said, this is a collaboration between Japan and this. So we share some experiments also on this. So one of the uniqueness of this one is this mission life is 100 Earth days, whereas Chandrayaan 3 was one moon day, that is almost like 14 to 15 days. Here we are trying to increase that into very high, very more number of days. And this is going to be the first ever detailed in situ study of a permanently shadowed regions. Means some of the craters on moon are in such positions that sunlight will never reach there. So these are permanently shadowed. Because of this, if there is any water or ice there, it will always be there only. Because there is no sun, it will not evaporate at all. So this is the best place to study what kind of ice it is there and what kind of water content we can expect from on moon. So this is going to be, we are going to do that near the South Pole. So this is the roadmap. So we have reached up to Chandrayaan 3. Now Chandrayaan 4 and Chandrayaan 5, see, both of them are planned in 2028. Okay. And then after that, so we want to send a person onto moon. Okay. So before that, we have to make sure that a person can go around the moon and come back safely. So we have to actually get expertise in many more technologies where we can bring back the person. So many more crewed missions are also planned. So then finally, we are planning to put a man or woman on moon by 2040. So, but why are we doing all these things again? So there are many experiments going on moon to grow food. So it is some of them are very successful also. After this, these are the reasons why anybody wants to attempt lunar programs. One of them is tourism. If somebody wants to go there and come back, if you have billions of billions money and if you don't know what to do, you can have a real honeymoon on there at that point. Because moon has 1/6 the gravity compared to Earth, so that can be a very good launching point for to go to other planets. So then we can have a base there, and then space tourism I just mentioned, and we might even have a something similar to ISS, International Space Station, around the moon. And this is the best thing. Whatever we are telling for all around, we can mine it for fuel and other minerals. By the way, this beautiful, magnificent resolution, this is by Buzz Aldrin. He's around 85 years now. He just got married last year. So not just lunar program, ISRO is also doing many more things, planetary exploration. For example, Aryabhatta and 2 rupee note is the where ISRO's most of the science programs started, and it went up to become Mangalyaan. So 2000 rupees. Unfortunately, both the notes are not in circulation now. So in 1963, we started our ISRO's science programs science programs with sounding rockets, followed by Aryabhatta, the first science mission in 1975. Then came Stage Rohini satellite series called SROS. On the SROS, the first proper X-ray, proper scientific payload went on that called IXPA, Indian X-ray Experiment. X-ray experiment, IXAE, astronomy experiment, and that was a very small satellite, but that gave 3 PhD theses, and that actually helped us in coming up with one of the best science observatory from India, that is AstroSat. This is the and then this followed by other many more payloads for SOX, solar X-ray spectrometer, and everything. In 2030, Chandrayaan, I have already mentioned that in 2008 we reached the moon. Reached moon means there is one terrain map, one probe. It just went and hit moon. Hence, we say that we reached moon. And then in 2013, India became the first country, again first country which reached Mars on its first attempt. Okay. So then even though Mars orbiter mission MOM is designed for 9 months life and it's only technology demonstration, it survived for 7 years. Then in 2015, AstroSat, India's first dedicated astronomy observatory mission was launched. So it was launched on 28 September. Now we'll be celebrating 10 years of AstroSat next month. It's still working fine and it is giving very good data. So not necessarily astronomy missions. We also have solar system exploration, entire solar system exploration. 2 years back, we launched Aditya L1 to study sun from Lagrangian L1 point. So this is one of the major people who are involved in Aditya L1. So this had multiple instruments, VELC, visible emission line coronagraph, which was actually realized in IAA. Then SOOT, Solar Ultraviolet Imaging Telescope, it is from Pune, Ayuka Pune. Helios, High Energy L1 Orbiting X-ray Spectrometer, this was realized at URSC. The name is given by me. SOLEX, Solar Low Energy X-ray Spectrometer, and other things. These are all the remote observations, whereas these are 3 are in situ measurements, means it will actually study around whatever it is there, whatever it is touching. That is PAPA, Plasma Analyzer package for Aditya, Aspects, Aditya Solar Wind Particles, and Magnetometer. So, Papa, I didn't. This is from the SSC. Okay, so this is at L1 Lagrangian point, not exactly at L1 Lagrangian point. It is in the halo orbit around L1. So it is so wide that a Lagrangian halo orbit, it takes 6 months for going one round. Okay, it's giving good results. So I have not shown any results here, but it's going fantastic results from VLC and SOOT. So Mars orbiter mission, I have already mentioned, it carried totally 5. These are the good thing about ISRO. We give fantastic names, Menka, Ramba, all sort of things. So it carried 5 payloads, even though it was for 9 months, it worked for almost 8 years. And it in 2023, we actually stopped the Mars orbiter mission working. So it has taken almost 1,000+ images. And since we have already shown that we have capability to go to Mars, and then we have the capability to land on moon. So our next aim is to land on Mars and study that one. That is called Mars Lander mission. So it is under consideration by ISRO. So it might be taken up after some time. So then naturally we have to go to Venus after Mars. So Venus mission is already approved. So we have selected the what are the science experiments all on board also. So we are finalizing the experiments based on the availability of mass and power. So this is going to be studying Venus atmosphere at around 60 to 100 kilometers height on Venus. So at 100 kilometers height, the atmosphere of Venus will be very similar to whatever we have here on ground. So because of the pressure. Okay. So then we are going to study atmospheric dynamics and composition, and like space weather on Earth, we are going to study Sun and Venus interaction. So these are some of the other justification for going to Venus. So this is under consideration. We might try it within few years. So then this is my favorite because this is the one which I'm taking care of. I'm involved with it from almost, you can say, day one. So India's first multi-wavelength astronomy satellite was launched on 28th September 2015, 10 years ago. And then it was launched to very low inclination angle of 60 degrees because to avoid what we call it as South Atlantic anomaly, where the charge particle density is very, very high and it can actually reduce the efficiency or it can even destroy some of the instruments. So this is a real national and international collaboration. This is a fine example of what national and international collaboration can do. So the most of the scientific payloads on board, which are around 5 scientific payloads and 1 auxiliary payload, out of them, 4 came from outside. So Indian Institute of Astrophysics actually made UV-80, ultraviolet imaging telescope, and then TAFR made 3 more instruments. So cadmium zinc telluride imager, large area X-ray proportional counter, and soft X-ray telescopes. So 4 of them. The 5th one, scanning sky monitor, was made at URSC, Space Astronomy Group, URSC. So except SSM, all the 4 have the same field of view, so that you will get simultaneous observations in multiple wavelengths, wide extended wavelengths from UV to very high energy X-rays. So this has actually, the data is has given, the data has resulted in almost 550 publications and 47 PhD theses has come out of AstroSat data. And in not only Indian institutions, even international institutions like Canadian Space Agency, which actually provided UV-80 sensor detector, and then University of Leicester, which provided the CCD for soft X-ray telescope. So totally, this is like a national and international collaboration. So AstroSat, it has observed a lot of different kind of varieties of targets, very close Alpha Centauri to farthest field at 9.3 billion light years away and in between. And so even though it is only what should I say, 40 centimeter aperture, UV-80 has 40 centimeter aperture, this can match JWST images. These are 2 JWST images actually with overlapping of AstroSat UV data. So this blue, dark blue, and the red are from UV-80, whereas the remaining colors are from JWST. You can clearly see that we actually compensate or not compensate. Complement. We can complement JWST very well with AstroSat. Sorry? 20%. I'll finish by that. No, I don't have the charger. So the reason why this has happened is we have almost 3 times better resolution compared to the next best UV-80 image instrument which is there, Galaxy. So you can clearly see this has actually given us the kind of data which we do. So future astronomy missions. So nowadays, everybody is working on exoplanets beyond our planet, solar system. So there are almost 6,000 known exoplanets discovered. So ISRO has plans to launch a mission to study some of these things, known exoplanets, to look for habitability. That is, to look for biosignatures from these exoplanets. We are going to use the transit method. So when the planet is in front of the star, if you take a spectrum, so that will be a combination of both the star as well as the planet. When the planet goes behind the star, then if you take a spectra, that will give you the spectra of only the star. If you take a difference of these two, in theory, you should get the spectra of planet. Okay, so that is the methodology we are going to use it. So we are going to use the primary eclipse, secondary eclipse, and the complete day and night time to actually study more than around 700 to 800 exoplanets, known exoplanets, to look for signatures of water or some other biomolecules. So this is going to go into L2 orbit where JWST is sitting. Okay, because the temperature requirements is almost similar to JWST, something like 40 to 70 Kelvin. So INSIST is from Indian Institute of Astrophysics. So based on the success of UV80, so IAA has proposed a mission with the 1 meter aperture. It's going to do a lot of other things in addition to spectroscopy of dense fields. So most of the times what happens is if you put a grating and you take a spectra, if there are two stars very close by, then the one star spectra of one star will overlap on the others and it will become very, very tough or almost impossible to separate them out. So most of the times we will not be in a position to study the dense fields. So what this does is we are trying to use what is called as digital mirror, micro mirror devices. Okay, this is just a system with mirrors which can be flipped. Okay, so and this flip can be programmed. Now, if you know which field you are going to observe in advance, you can actually program this mirror, DMD, such that some of the mirrors can be flipped in one angle and some of them can be flipped in the other angle and some can be retained there, so that this whatever the spectra can be spread over the large CCD sensor, the 8K by 8K, so that you can get multiple spectra of multiple stars close by. So this is in under consideration. Then there is a Daksha. This is the Indian Eyes for Transient Skies. This is the main aim of this is to study the electromagnetic counterparts of gravitational wave events. So this is going to have three sensors covering low energy from 1 keV to more than 1 MeV with three sensors. And these three sensors are actually on the satellite such in a different direction so that you can cover the entire half of the sky, and using two of them at any time you can cover the entire sky, 360 degrees of sky. Okay, then there is Pratyush. So this is the first time ISRO is going to attempt observations of sky in radio. So this is Pratyush is from probing reionization of the universe using signal from hydrogen. He is from Raman Research Institute. So this is going to look for 21 centimeter line from hydrogen. So with this, they are planning to study the cosmic dawn or epoch of reionization. So what we have done till now, these are the plans we have for moon and others. So our aim is to see by 2040, we'll change this heading into Indian land on moon. Okay, our chairman is also of the same opinion. We want to put a person on moon by 2040, and in addition to that, we want to have our own space station in space by 2035. So today, just yesterday, the model 1:1 model of the space station was like shown at Delhi. So there you can see the size. You can clearly see the kind of size what we are planning. It's almost going to be 40 ton total the total Bharatiya Antariksh Station. We want to put it by 2035. So I'm coming to my last slide. Oh, videos I missed. Two videos I missed. Okay, so I'm coming to the last slide. You know that in 2 years back on this day, so we landed on moon. Okay, so this we call it as our Prime Minister, Honorable Prime Minister has called this as the Shiv Shakti point, and this is actually image or photo taken by the rover. Okay, this is a rover picture, and this point is called a Shiv Shakti point, and very close to the Shiv Shakti. This is the Shiv Shakti point, and very close to that we have some rocks. We lovingly call them as Nandi. Thank you all.
Thank you so much, Girish. I think many of us thought the moon is a lifeless and fairly boring thing out like a constant companion. Yeah, please.
I have the videos in the next slide. I don't know somehow that I went to know. I'll show you some videos. I'll just take 2 minutes if you have.
Yeah, please.
This is the Pragya. It's a rover when it actually got down on the moon and it rotated there. These are the videos. I might have some 10% battery.
It's like
And I told you that when we actually went there, because to be on the safer side, we had more margin of fuel. We carried little more fuel than whatever we wanted to reach moon. So when we successfully landed on moon, okay, we had enough fuel. So we did not know what to do with it. Then we decided, we thought that, okay, tomorrow we are going to attempt coming back from moon. So why not we try it out? So we did an experiment. Sorry. What we did, what we did was using that fuel, we tried to see whether we can jump from moon. This is the result of that. We go to the different place. Okay. So what we did was we just jumped from there, hop from other place. So with this, we actually proved that we can actually take off from moon. Not only this, even in the orbiter, we had a little extra fuel. So instead of just wasting the fuel, what we did was we brought back that orbiter module. So it is not going around. Chandrayaan 2 is going around moon, but Chandrayaan 3 orbiter module is not around moon. It is actually in the Earth's atmosphere, Earth's orbit. So we even proved that another technology. So two things we proved with Chandrayaan 3 in addition to soft landing. Not only this, you are all aware of that we landed on moon in 1965. Man landed on moon in 1965. 69. Thank you. 69. Thanks. Almost 60 years back. But whatever Americans achieved almost 50 plus years back, they stopped after some time. They stopped